with the formula. The reason I'm not going to do it with a formula is because I think that sometimes we do things with formulas and they don't make any sense. Okay, like I told you, which is what's going to happen when I give you back your quizzes. And you're like, why did I get my answer wrong? I'll be like, because you used a formula and you didn't make any sense of it. Okay, so to do this problem, I'm going to do it in 2 different parts. The first part that I'm going to do, I'm going to think a little bit critically here about these semicircles. I know there's one semicircle on the front, and then I've also got one on the back, yeah? So I'm going to find the area of those 2 pieces first, and because I know my diameter across the whole circle is 25, that means I know my radius is 12.5. Right? My radius is 12.5 feet. So to find the area of that circle, again, putting the front and the back of this together, the area of this circle is going to be the radius squared times pi. The radius is 12.5. So 12.5 squared times pi. I'm going to again leave this in terms of pi because I feel like it. This is going to be 156.25 pi square units for those 2 pieces there. Okay, so for the front and for the back. Again, I'm not so good at memorizing formulas, and I don't think there's a real need to. If I just think about it critically, then I don't miss anything. Okay. The next piece that I'm going to find the area of is this shaded in piece. So this here, right? What is this piece of the circle? Say louder. Circumference, right? So I have this circumference and I can kind of picture it. It's wrapped up around the top of this circle, right? The whole like dome of this. I know. Come back. Talking about the area of this piece, right? If I laid this flat, we said this was the circumference, but it's not quite the circumference, right? What is this compared to the whole circle? It's half the circumference. So if I'm thinking about this thing, right, this is half the circumference, and then it has the rectangular piece. Okay? It's half the circumference times that 50 feet. This is me drawing it out flattened, right? So if I take that and I flatten it out to a flat circle, this is half the circumference times the height. Okay? That would be the area of that piece. So since it's half the circumference, I know that the area of this thing, what's the circumference? How do I find it? Twice the radius times pi, or diameter pi. So I'm just going to go ahead and say it's the circumference of the whole circle. The circumference of the whole circle would be 25 pi, because the radius is 12.5, but the whole diameter is 25. So the circumference of the whole circle would be 25 pi, but since we're only dealing with half the circumference, I would say that it's going to be 12.5 pi. Okay. So finding the area of this piece, it's a flattened out rectangle, is just 12.5 pi times 50 feet. So 12.5 pi times 50. 12.5 times 50 is going to leave me with 625 pi square units. And that's that pink piece right there. Right, so this would be all of that flattened out part this way. So that's 625 pi. So to find my total surface area, right, the total surface area is going to be this plus that, 156.25, and I'm going to have 781.25 pi, not square units, I guess, square feet. Okay. 781.25 pi square feet. Do the whole surface area. Okay. All right. Questions about that whole thing? Yes. I didn't multiply my numbers by pi. So like right here, if you did that last step to multiply it by pi, you'd get a different answer. If you multiplied your whole answer by pi, you would have 2,453. 2,453 would be if you multiplied this by pi. So really what we're doing is learning two things: to leave things, pi is just a number, and pi is just multiplying by 3.14. And instead of doing that, I'm leaving this as an exact answer. Okay, that's more of an exact answer. So that's a thing we're building towards being able to do. Okay. Any other questions? All right. Oh, this worksheet. I want you guys to talk about this. Mostly talking about these similar shapes. I'm just going to give you guys 5 minutes. We got a lesson. Okay? So you have 5 minutes to talk about your homework. The really important piece that I want to talk about is on the back. Make sure everyone has the same stuff on the back. If your rectangles look different, they're not the same. Okay? So make sure everyone's really solid on the back. Take 5 minutes to talk about the front and the back. Ready, set, go. All right. That's been 10. Trinity, very bad timing. Okay. So when we're talking about this guy, important to note, please, that a few things looking around. That first rectangle, the pink rectangle ABCD, is labeled. Each point is labeled. The second rectangle is also labeled with A prime. That's what that little apostrophe is there. A prime, B prime, C prime, and D prime. That would be the correct enlargement of the second rectangle. Okay. Looking at this first rectangle though, A, B, C, D, what's the area there? Say? 12? Is that what you guys are saying? 3 by 4? Right, so the area here is 3 times 4, which is 12 square units. Make sure you're including units. I told you some of you guys were going to cry when I give you your quiz back. Okay. Make sure you're including units, even if they're just square units. Okay? Even if they're just square units. When I'm finding the area of my new enlarged rectangle, now, let's think about this, right? I made the rectangle twice as big, yes? Yeah? So instead of being 3 right here, how long is this side? 6, and instead of being 4, how long is this side? 8, right? So I make the rectangle twice as big. And what happens to the area? OMG. Okay? The area becomes 4 times as bigger. If I made the rectangle 3 times as big, anyone want to guess what would happen to the area? 6? 9? Let's check it out. If I make this rectangle 3 times as big, so I'm going to go back to my original rectangle. I'm going to make it 3 times as big. So there's my new D prime, I guess double prime, 2, 2. Here's my new A prime way out there, double prime. B prime now is way out here. And C prime is way out here. So now this purple rectangle is 3 times bigger. This purple rectangle is 3 times bigger than my original rectangle, right? So my original rectangle had a side length of 3. This now has a side length of 9. It was a length of 3, I guess, I don't know, and a width of 4 on the original rectangle, and this new rectangle has a width of 12. So when I'm finding the area now, 9 times 12, 81, 90, what? 99, 108. What's 9 times 12? 108. How much bigger, how many times bigger is 108 than 12? We just did it, right? So this, when I make the sides 3 times bigger, the area was 9 times bigger. When I made the sides twice as big, the area was 4 times bigger. Okay? Because area is what kind of measurement? Square measurement. So 2 squared is what? 3 squared is what? If I make the sides 4 times as big, what do you think is going to happen to the area? We'll get there. We'll talk about it later. Okay? We'll talk about it later. On the front, are those all similar?
No.
What's not similar there? D? What's not similar over here? Why not? Is it allowed to be flipped? I'm going to pull you guys back to what we were talking about last class. Last class, you guys said that D was still similar even though it was flipped.
No.
Let's talk about it. What? No? Okay. We'll keep working on it. Here's what we're going to talk about. Here's where the official definition. We're technically in G2 right now. Don't look over there, it's wrong. When talking about similarity, I said don't look over there.
Why not?
Because those are wrong. The definition of similar. The definition of similar. Here's the official definition. You shouldn't be talking, you should be writing. Corresponding sides are proportional and corresponding angles are equal. Okay? The corresponding sides are proportional. The corresponding angles are equal. Okay, that's the official mathematical definition. As an example, we're going to have some similar examples, and we're going to have some non-similar examples. 2 shapes that are similar. This right triangle is similar to this right triangle. One way that I can think about it is because each side is proportional to its corresponding side. From 1, looking at this side 1, what's the corresponding side length on the bigger triangle? 1 corresponds to which side, the 3 or the 6? The 3. And what's the scale factor from 1 to 3? What am I multiplying by? 3. And notice, so I'm multiplying by 3, and that's the same thing as from 2 to 6. Right? That's the same thing from 2 to 6. That both sides are scaled by a factor of 3. Notice the language that I'm using. I'm not just saying that for fun. Okay? Both sides are scaled by a factor of 3. Okay? I can also point out the fact that if I look within the triangle, right, if I compare 2 to 1 or 1 to 2, right, if I compare 2 to 1, that's the same thing as comparing 6 to 3. The ratio is equal here, right? 2 divided by 1 is the same thing as 6 divided by 3. The scale between the sides are the same, and the ratio within the triangle itself is the same. As a non-example here, if I have this rectangle, a 2 by 3, versus a 3 by 4. Okay. Yes, right? The corresponding side to 2 is what on this bigger rectangle? What? 3, right? The 2 is the shorter side, the 3 is the shorter side. So the 2 corresponds to the 3. And there's something that I multiply by. From 2 to 3, I want you to find the scale factor. From 2 to 3. What's the scale factor? 2 times what is 3? Confer with your table. Double check. Confer with your table. Don't say weird stuff to me. Times 1.5 is 3. This is true. And if I'm checking the other sides, 3 times 1.5 does not equal 4, right? 3 times 1.5 does not equal 4. This doesn't work. Bad things are happening. Bad things. Bad things are happening. It's not equal to 4. That's bad. Right? The sides don't have the same scale. Another way I can say that is when I'm comparing between the two triangles, 3/2 is not the same as 4/3. Right? Those aren't the same fraction. Okay? Those two rectangles are not similar. Okay? We're going to do, I think, one example. Here's how we're going to be using similar triangles. The two triangles are similar. The two triangles below are similar.
Do you want to write this?
Yes, write this. The two triangles are similar. Find the missing side length. Here's the first triangle. Triangle 1 is A. Triangle 2 is B. I want to know the missing side length. The two triangles are similar, meaning they are scale versions of each other, meaning there is a scale factor. Find out that missing side length, please. If you're not sure, try and find the scale factor. How many times bigger is B than A? Find it out. The two corresponding sides you know. How much bigger, how many times bigger is B than A? Essentially this. 4 times what is 6? Find it. Find it. What?
I know we should have.
Okay, so when I'm trying to find the missing sides, I need to first find the scale. Okay, so triangle B is how many times bigger than A? Trinity, go ahead. How did you get that? Okay, you guessed. Okay, so if I do, right, essentially if I want to know 4 times what number gives me 6, That means when I do 6 divided by 4, I get 1.5. Now, if I'm you, I check every single time. Every time I just do a quick check to make sure that 4 times 1.5 is 6. And I'm like, oh yeah, okay. So 4 times 1.5 is 6. That means if I multiply 7 by 1.5, I should figure out my missing side. And when I multiply 7 by 1.5, what do I get? 10 and a half units. Okay, I get the answer of 10 and a half units for that missing side. Okay? Excellent. Now, here's what's next. You're going to get your quizzes back in a second. Okay? I'm going to call you up. If you're in this aisle, this is the main aisle. I need everyone to come up from this aisle, so you're going to need to slide in and face, just look at that wall. Okay? You're going to come up this way. I don't care where you're coming from. All of you are going to come up this way. You're going to grab your quiz from me. You're going to grab one of these worksheets for yourself, and then you're going to return back that way to your seat. Okay? Come this way, get your quiz, get a worksheet, go back to your seat. Okay? The other thing, is that if you, two things. First thing, I guess. Your score is your business alone. Okay? You shouldn't be asking anyone else what they got, because it's none of your business what they got. Okay? Also, when you start comparing, I think that's a pretty fruitless exercise. There's no point in comparing to other people. All right? It's all about what you need to do to improve. Okay? So you're going to get your quiz. You're going to get this practice worksheet. You're going to go back to your seat. The second thing I should tell you is that these are not in the grade book. They're not in the grade book because I can't put in grades for you yet. I told you this already. I have a meeting about it this afternoon. I don't know. It's a district level problem, and it's very frustrating. Mystery, will you help out your phone?
Oh, that's my phone.
Yeah, I know. Blinding me. Don't answer. Get off. Just make it. Okay. Ibrahim. Okay. If I don't get this back, you get a 0 on your quiz. I'm hoping that I can enter grades by, today, because progress reports are due tomorrow, so we'll see. Also, okay. So I can't enter grades. This isn't in your grade book. So when I go to put this in your grade book, I'm sure this problem will be resolved today. You will get a 0 if I don't get your quiz back. Okay. So I'm going to recollect these from you. Okay? You're going to come up, grab your quiz, grab a worksheet, go back to your seat. Mind your own business. Your grade is your thing and no one else. I'm going to call you up. All right. Ready?